Good morning, everyone, and welcome to the second International College Conference on Advanced Innovation in Smart City. My name is Dr. Zainab Rabia. I am honored to introduce today's speaker in this session. The conference is hosted by Jeddah International College in cooperation with IEEE. Each presentation will have 15 minutes for their presentation, followed by 5 minutes for questions. Dr. Farah? دكتور فرح
Yes, السلام
we
عليكم.
can اوكي ممكن تبدأي ممكن تعرضي البرزنتيشن بتاعك
Okay. I send the request for sharing.
اوكي 1 minute we can start أستاذة فرح ممكن تبدأي
Okay. Good morning, everyone. I am Farah Jarbour, and I'm honored to present our paper titled Exploring AI Applications for Optimal Business Location Selection in Smart Cities, a literature review. This paper was conducted in collaboration with my colleagues Halal Hazza, Janal Blehid, Jul Al-Qahtani, and Reem Al-Hazzani, under the guidance of Dr. Sumaya Al-Jamil and Dr. Deem Al-Qahtani at Imam Abdurrahman bin Faisal University. Together, we explored how AI-driven approach are revolutionizing business location selection in smart cities through a detailed systematic literature review. To provide a structured understanding of our paper, this presentation is organized as follows: introduction, background, objectives, methodology, resultant discussion, and in the conclusion, we will provide final insights and recommendations. Smart cities need smart decisions, and one of the smartest decisions a business can make is choosing the right location. But in a world of growing complexity, how can artificial intelligence make this process smarter, faster, and more accurate? As urban environments rapidly expand, new solutions are needed to optimize resource distribution and the economic growth. So smart cities require strategic planning to ensure businesses are positioned efficiently and sustainably. And one of the most critical factors in this development is the business location selection. So choosing the right site can significantly impact its success and urban balance. However, traditional site selection methods often fail to capture the full complexity of modern urban dynamics. So this is where artificial intelligence plays a transformative role to address this complexity, which can analyze large-scale data, predict high-demand area in the city, and offer data-driven insight to enhance decision-making in site selection. So selecting the right business location is not just about finding an available space. It's a strategic decision that shapes long-term growth, profitability, and sustainability of that business. And the location of a business can determine its accessibility and customer reach, also its overall success in the market. And because of this, location choices carry out significant weight. Unlike other business decisions like pricing or marketing strategies that can be adjusted over time, the business location is difficult and costly to change, making the initial choice crucial for long-term success. Also, the site selection is not a straightforward process. Urban environments present multiple challenges, like businesses must carefully evaluate the demographic trends, the infrastructure, local competition, and all of which can influence the success of that business. And still, many businesses rely on intuition rather than the data-driven insight. And this is where AI can be a game-changing solution by leveraging predictive analytics and processing vast amount of data to identify optimal business location with impressive results. So our paper aims to the following objective. First, we seek to provide a comprehensive overview of existing research on business location selection leveraging AI approach. We aim to explore AI technique implemented for site selection process. And since the site selection depend on multiple urban factors, so we also want to investigate the key factors influencing AI-based location decisions. Additionally, we aim to analyze the effectiveness of AI models in finding the optimal business location. And finally, as AI adoption varies globally, so we want to identify which countries are leading in the AI-driven business location selection. So our paper follows a systematic literature review methodology, and to maintain transparency and reliability, we added to the preferred reporting items for systematic reviews and meta-analysis, known as PRISMA framework, which provide us with clear steps for selecting and reviewing studies to ensure that our review process is comprehensive and methodologically sound. So our study is driven by 4 main research questions, each aimed at understanding how AI contribute to business location selection. So first one is, what are the most applied AI techniques in selecting the business location? What are the most considered factors in the site selection process? How effective are AI models for business location selection? And finally, which countries are leading in the adoption of AI for optimal business location selection? So we conducted the search process across the databases IEEE Explore, Scopus, and MDBI, and we designed predefined search queries focusing on key terms, AI and location. And our approach included variations like AI and retail location selection, optimal location, and store placement to capture different perspectives. And the queries were refined iteratively to ensure relevance and coverage. So this strategy enabled us to gather a diverse set of research articles, forming a solid foundation of our study. As I mentioned previously, that we have followed the PRISMA framework, which helped us filter and refine the research studies step by step. So as shown in the diagram, we started with an initial search across 3 major databases, IEEE Explore, Scopus, and MDBI, which yielded 211 studies. And some records were removed before screening, as we have duplicate record, and other record was removed for other reasons. Next, at the screening stage, we screened 157 studies by reviewing their titles and abstracts, and the goal here was to identify research that focused specifically on AI applications in business location selection, and 84 were excluded. After the first screening, 73 studies were selected for a deeper review, where we have examined their full text version to check the quality of the research and their methodology. And there are 14 studies were inaccessible either due to paywalls or restricted access. Then we analyzed 59 studies in detail, ensuring they met our inclusion criteria that will be discussed in the next slide, and 38 were excluded. At the end, we had 21 high-quality studies included, forming a solid foundation for our review. So to ensure our review is based on high quality and relevant studies, we applied the following inclusion criteria. First, recent paper, we included only studies published between 2016 and 2024 to capture the latest advancement in AI for site selection. The relevance means that the study must explicitly apply AI techniques, ensuring a strong connection to our research focus. Primary study means that we want to include only the original research proposing new methods, excluding the secondary studies like surveys and reviews. The accessibility means that the paper must be retrievable from specified academic databases to ensure transparency and credibility. For the originality, to avoid redundancy, the duplicate papers were removed, ensuring that every study contributes a new insight. And finally, which is the most important one, is the data sources and sizes, means that the studies had to clearly state their data sources and sample size, allowing us to assess the reliability and validity of their findings. So going to the result and discussion, to answer the first research question, what are the most applied AI techniques in business location selection? We analyzed the studies included in our review and identified the most frequently used models. So as you can see in the bar chart, it highlights the dominance of random forest due to its high accuracy result and ability to process large data sets, followed by the decision tree and SVM. And this confirmed that tree-based models were the most used for business location selection. Then the neural networks and logistic regression were used in 4 studies, each showcasing their adaptability in tackling this problem. Also, more advanced models employ neural networks, particularly because of their ability to recognize nonlinear correlation in the data. Similarly, 4 studies used KNN that forecast site suitability based on proximity to other successful businesses. Also, there are 2 papers used more specialized method like the LambdaMod and GPM. And these methods were applied to ranking tasks when dealing with complex and multidimensional data. Moreover, some papers incorporated custom optimization algorithms such as Minimax, a priori, and Calypso, and they were often tailored to satisfy certain needs of the researchers in order to address unique challenges. So for the second research question, what are the most considered factors in the site selection problem? Based on our analysis, site selection depends on 4 key factor categories. The demographical, including the population characteristics like age, income, and density. The geospatial, related to the physical location aspects such as accessibility, road networks, and proximity to competitors. The behavioral, related to the customer behavior and the social media interactions. And finally, the operation, which considers the sales performance only, showing which location attract more revenue. So this table illustrates the factors used in the studies. As you can see, the demographical factors include population density, gender, age, and income, and this helps businesses to understand their target market. And the studies use government and open data source to collect this data. Then the geospatial factor, which is the most frequently analyzed category, appeared about 90% of the studies. It includes point of interest density, competition, transportation, and area popularity, and all of which are essential for assessing the accessibility and business potential. And most of the studies use Google Maps, OpenStreetMap, and BidoMap to collect this data. Then the behavioral factor focused on the customer movement, point of interest popularity, and the demand distribution. And the studies used different platforms to collect this data, like Facebook page, Instagram, and Yelp, to collect the customer data. And finally, the operational factors. Sales is the only factor in this category, appearing about 19% of the studies. AI models are proving to be a powerful tool in business site selection, but their effectiveness depends on how they are measured. So to answer the third research question, how effective are AI models for business location selection, the studies used 3 key performance metrics, either classification, regression, or ranking. This variation reflects the diverse problem types considered in pursuing a unified objective, which is the formulation of effective AI model for business location selection. So as you can see in the figure, 38% of studies evaluated their AI models based on classification metrics, 24% based on regression metrics, and 9% based on ranking metrics. And some studies used a combination of these metric types to give a more comprehensive understanding of model effectiveness. However, 19% of them didn't offer any evaluation focusing on theoretical contribution rather than practical performance assessment. For the studies that applied classification metrics, which is used to predict whether a business location is suitable or not for a business, the XGBoost classifier yielded 94% accuracy for one of the studies, which provided valuable site recommendations for various businesses. And in terms of regression metrics, the minimum relative absolute error were reported in one of the papers, which ranging from 4.7 to 6.9% by the MLP regression, which was used in a real-world case to recommend business site selection in London City. Also, a study made in Beijing shows the power of employing random forest to predict suitable location for coffee shops, which resulted in a coefficient of determination 0.929. And for ranking metrics, which are used to prioritize the best location by ranking them in order of suitability, the model successfully ranked store locations for major brands like Starbucks, and they demonstrated a very high performance of Random Forest and Lambda Mart in the coffee shop and hotel businesses. And actually, one of the most impressive results was by an author who built a framework that was tested on real-world businesses, which was on Hadlieu store. It's a popular hotspot restaurant in China, where the predicted sites were to be very close to the actual store's placement, and it's specifically the calculated location were only far away 200 meters from the real store. And finally, to address the fourth and final research question, which countries are leading in the adoption of AI for optimal site selection, we analyzed the geographical distribution of the research papers. As illustrated in the figure, China emerged as the leader in this domain, contributing 9 studies, which underscores its strong focus on smart city development and AI-driven solutions. Malaysia follows with 4 papers, indicating notable interest in this field. Then France has contributed 2 papers, and the rest of countries each contributed in just 1 study. And actually, this distribution highlights that while some countries are investing significantly in AI for site selection, others show limited engagement, suggesting that opportunities for future research expansion and international collaboration in this evolving field. In conclusion, this systematic literature review highlights key insight into how AI applications for optimal business location selection. And this review revealed the predominant use of machine learning, particularly classification algorithms, and the primary focus was on demographic and geospatial factors in selecting the optimal business location. And most of the reviewed studies applied various performance metrics to validate the effectiveness of AI in selecting the optimal business location. However, only few studies have validated models in real business cases, leading to a need for more real-world testing in this field. Also, there is a noticeable absence of geographical diversity among the publishing countries, with the studies concentrated in a few countries. And this suggests opportunities for further studies across different countries to provide insight into how local conditions impact the business location selection. Also, incorporating the customer behavior analysis can further enhance the AI-driven decisions. Thank you all for your time and attention, and I appreciate the opportunity to share this paper with you today.
Thank you, Dr. Farah. Any question? Thank you. Dr. Nusiba,
Yes, I'm here.
you can start. You can share your presentation.
Okay.
Dr. Nusiba, ممكن your presentation? Share your screen.
Let's see now. Okay. Can you see me now? Or can you see the presentation?
No,
No?
1 minute. 1 minute. Okay, you can start.
Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. I am Nusayba Mohammed Al-Ahdal, a master's student at King Abdulaziz University from the IT Department, Faculty of Computing and Information Technology. I'm so happy to present my project to you. This project is supervised by both of Dr. Falwa Abu Khair and Dr. Asma Sharif. They both are part of the management team of Center of Excellence in Smart Environment Research at King Abdulaziz University. Here is the presentation flows. As an introduction, our use case is about the smart vehicles, the autonomous vehicles that represent a transformative shift on the world because it combines the advanced technology like AI, machine learning, and the hardware to transform and navigate the world to use the technology without any human interacting. And the foundation of these smart vehicles is the object detection technology because it's ensure the safety and the efficiency and making a reliable decision making in these smart systems. However, on these autonomous vehicles, the traditional centralized systems, because it rely on accurate and real-time object detection, face different challenges. First, like data privacy, scalability issue and centralized model, also the need for sensitive data sharing across devices. On the privacy concerns, the centralized system require the transfer of raw sensor data to centralized location for processing, risking the sensitive information to be exposure. Also, the scalability, the centralized solutions struggle to scale effectively as the number of connected devices or vehicles grows. So our proposed solution focus on integrating the video learning technology. As you can see, here is our model structure. It integrate the last one of the last version of the famous YOLO model, which is YOLO version 8, with the federated averaging technique to managing the privacy and the scalability issues. Because this federated learning technology doesn't share the sensitive data on the centralized system. It just share the parameters, but keep the raw data and the real data on the local devices. In our case, as the devices here is the smart cars. Also, in our proposal, we used our custom VSIM dataset. We developed this dataset to be simulator data that represent the autonomous vehicle environment. So our proposed solution has key benefits. For example, it provides the privacy, it provides scalability to diverse autonomous vehicle environments. Also, it improves the accuracy and adaptability. On the technical approach, our data set that we developed, it's a custom simulator data set for multiple classes, detect the cars, humans, road signs, and bikes. You can see here the samples of this data set. Here, human on side road, car, also cars, and road sign and bikes, to represent this environment on different scenarios. On different classes. Also, we use the federated learning technique. This technique enables decentralized training, maintaining data on local devices. We use the averaging approach to optimize the management, privacy, and scalability. And because it's the simplest approach of federated learning, we use the YOLO version 8 model. It's famous because it's high-speed, accurate object detection, detect the different object on different scenarios on real-time autonomous vehicle systems. Our criteria and assessments measures, first was the precision, to measure the accuracy of positive prediction made by the model, and then the recall, to measure the model's ability to detect all the positive instances of the class. And the last one was the mean average precision, to evaluate the precision recall trade-off across all object classes. We achieved these metrics. The mean average precision was 8,600%, the precision was 8,400%, and the recall was 8,300%, compared with the traditional centralized model, and proved that it's better. Our proposal is better than centralized system across all these metrics. There is a published work related to this project. The first one was real-time object detection on autonomous vehicle with YOLO. We published it on a conference that it present an early investigation of using YOLO for object detection in autonomous vehicles, highlight the potential for real-time application. Then we applied to this conference by after we integrate the federated learning technology to this project and compared with the previous work. On conclusion, we propose a privacy preserving framework that integrate YOLO version 8 with centralized with federated learning and compared with a centralized system for autonomous vehicle object detection. Our proposal is approved its effectiveness and get a high mean average precision across key object classes, proving it's suitable for real-time autonomous vehicle application. And also in our proposal, there is a balance between the accuracy and privacy, make it a good alternative for the traditional and centralized model. On the future, we are working on exploring a different approach for federated learning, which is the gradient harmonization. And because we want to solve the non-identical data issues in this use case, and expanding, we want also to expand the data set. We want to expand data set with diverse object and environmental conditions. and conduct real-world trials to assist robustness and dynamic autonomous vehicle scenarios. Thank you so much for your listening and giving us this opportunity.
Thank you. Any question? Dr. Dalal,
Yes, I'm here.
can start. You can share your presentation.
Assalamu alaikum wa rahmatullah. Good morning, everyone. Allow me to introduce myself and my supervisor. My name is Dalal Fathi, a master student at King Abdulaziz University. I'm joined today by my supervisor, Dr. Afra Atiya, and co-supervisor, Dr. Abir Hakim and Dr. Asma Sharif. Our topic for this presentation is reinforcement learning for intrusion detection, recent advance and dataset, and we are excited to share our insight and finding with you. Our research review recent development in intrusion detection using reinforcement learning technique. By exploring this approach, we aim to provide an overview of the current state of reinforcement learning-based intrusion detection system and their potential to improve cybersecurity. We also highlight the important role of feature engineering in combination with reinforcement learning technique. Additionally, we present and analyze the dataset frequently used in conjunction with this reinforcement learning method, offering insight into the data resource and support the development and evaluation of this advanced security system. We indicate that cybersecurity are become sophisticated, making detecting increasingly challenging. Traditional intrusion detection have difficult to identify advanced threat. As a result, current methods fail to keep up with the new security challenges. Reinforcement learning presents a solution by allowing intrusion detection system to learn from a feedback, using reward to enhance decision-making and improve threat detections. Our objectives are provide a comprehensive review of reinforcement learning technique applied to intrusion detection system, also analyze the latest advancement in reinforcement learning-based intrusion detection system. Additionally, emphasize the role of feature engineering in optimizing intrusion detection system performance when integrated with reinforcement learning technique. And finally, review commonly used dataset for training and evaluation reinforcement learning-based intrusion detection system. Firstly, what is intrusion detection system? It is a security mechanism that continuously monitor a network or system activity to detect malicious behavior or policy breach. There are two primary types of the intrusion detections: signature-based detections, which identify threat by matching predefined attack pattern, and anomaly-based detection, which detects suspicious behavior by learning normal system activity and flagging deviation. However, as a cyber attacker continuous evolving their strategy, intrusion detection system face challenging in maintaining its effectively. One of the defense against attack technique is reinforcement learning technique, which is a type of a machine learning where our agents learn to make a decision by taking an action in an environment to achieve maximum cumulative reward. It's particularly effective in a scenario where our agent must interact with an environment and learn from a feedback through a system of reward and punishment. The key concept of reinforcement learning are the agents, which the entity that make a decision, such as a robot or a software; environment, the external system, which the agent interact; state, which represent at a specific time; and action, the choices that can change the state; finally, the reward, which is feedback from the environment. Reinforcement learning is divided into several subfields. These subfields include method and strategy used to enhance learning efficiency, adapt to complex environment, and improve performance. The main classification include traditional reinforcement learning, which include deep reinforcement learning and adversarial reinforcement learning, then inverse reinforcement learning, and finally, hybrid reinforcement learning. In a traditional reinforcement learning, adversarial reinforcement learning is a framework combining concepts from reinforcement learning and adversarial training. It involves two agents, agent classifier and agent environment. The agent classifier identify and classify network intrusion and anomalous activity, while the agent environment challenge the agent classifier to adapt and improve its detective capability against evolving threat and attack strategy. Another traditional reinforcement learning called deep reinforcement learning technique, which combine reinforcement learning with deep learning technique, enabling agent to make a decision based on a complex and high-dimensional data. Deep reinforcement learning uses a neural network to help an agent to decide how to attack. This network estimates two main things: the agent policy, which guides its action, and the value function, which predicts expected reward. Another technique called inverse reinforcement learning. The image shows the difference between reinforcement learning and inverse reinforcement learning. In A, reinforcement learning learn a policy by maximizing knowing reward from the environment, while in B, inverse reinforcement learning start with an optimal policy, which is an expert behavior, and learn the reward function that explains it. So the key difference: reinforcement learning learn how to act based on reward, while inverse reinforcement learning learn the hidden reward from the expert actions. Hybrid is the last technique, which combines two different models. This model aims to leverage the strength of multiple reinforcement learning techniques to overcome the limitation and improve performance in a complex decision-making task. To enhance data representation in machine learning model require feature engineering, which include techniques such as feature transformation and feature selection. In a feature selection, identify essential data component in the process of identifying and selecting the most important feature from the dataset. While in the right picture, feature transformation, optimizing their representation involves modify existing feature into a new representation offered by applying mathematical function or combination to improve a model performance. To go deep in feature selection, the feature selection involves identify the most impactful feature in a dataset. This process lower dimension and computation requirement, and then it can implement using automated method such as filter selection, which select a feature before model training, and rubber technique, which select happen iteratively while the model is training, or through embedded method, which promote feature selection during the model training process, for example, LASSO. The table presents a summary of reinforcement learning-based technique used in intrusion detection system. It categorizes the method based on the reinforcement learning approach, feature engineering technique, method selection, algorithm use, and performance metric accuracy and F1 sticking. The best performance in the term of accuracy, the model that have hybrid approach or an adversarial environment, as we show in the table. Also here, the table provides an overview of the data set used in reinforcement learning for intrusion detection system. The NCL-KDD dataset appears the most used dataset in the reinforcement learning-based intrusion detection, as it refers more than one other dataset in the table. This highlighted significant for intrusion detection system evaluation. To conclude, reinforcement learning has emerged as a powerful approach to enhancing intrusion detection system by enabling adaptive and intelligent threat detections. Various reinforcement techniques, including adversarial reinforcement learning, inverse reinforcement learning, contribute to improve intrusion detection system effectively. Feature engineering play a critical role in optimizing intrusion detection system performance by refining data representation through feature selection and transformation. Finally, the choice of the dataset significantly impact in training and evaluation of the model, ensuring the robustness and detecting capability. Thank you for your time. I would be happy to take any question or hear from your thought.
Okay, thank you, Dalal, for your presentation. Is that your thesis? Is that your master's thesis?
Yes.
Okay, so good luck. Good luck for you. Okay,
Thank
so
you.
anyone have a question? Dr. Zainab? Okay, thank you. And what about Jeffrey? Are you there, Jeffrey? You can start now.
Yes, I am. Just a minute.
Okay, can you share your screen, please?
Uh-huh.
Okay, we can see your screen. You can start, please. Go ahead.
Okay. All right. Thanks for having us. We're honored to be here. Wish we were there in person. We're from the USA, Brazil, and Europe, and really the technology base is now out of Brazil. I'm currently in Brazil. So we'll do a little overview here, give you an introduction. The experimental focus is on multi-level AI and vehicle automation using 5G, 6G technology. We'll talk about what the key technologies are. We'll do some comparison with existing smart cities frameworks, and we'll do some real demonstrations of our 5G energy IoT platform and drone over a public cell network in a city, and then some future directions. All right, so as I said, experimental focus for us is we had an existing 5G, 6G for AR/VR R&D project for the U.S. military. And the big feature there is this business of using, embedding cloud computing into the cell network infrastructure so that you provide advanced application services, lower latencies. And then the idea of being able to segregate traffic into from different groups, so high security, low security, for example, something called network slicing. And then we had a cloud-based autonomous vehicle navigation project as a separate thread, and then we want to put those two things together. And the end result where we wanted to be was to be ready for that real-world pilot project and deployment. That's where we think we're at. And so folks know all about smart cities, but we all kind of assume that there's going to be some high-speed communication networks that enable this real-time decision-making and data management. And so you're going to see what we think are some real 5G, 6G network infrastructure that can provide that backbone for your dense, complex urban environments using realistic frequencies. And these networks are delivering the kind of performance that you need. And if you've got this capability of putting cloud computing close to the cell phone tower, close to the user, it makes sense then to think about multi-level AI that then utilizes what we call multiple access edge computing, MEC computing, and cloud integration to enhance the function of everything. All right, so this is the main graphic here is showing you some of the real terminology of the cellular network field. So it's going from left to right, user equipment, that's your smartphone or other devices. Inside your device, you have something called a UE modem. That's what actually talks to the cell phone tower and gives you network connectivity in your device. Moving over next, that UE is talking to over the air through an antenna to the radio unit. That's your cell phone tower radio, RU. there then has to be something that converts radio waves into internet traffic, and that's your radio access network, RAN. The RAN is composed of a distributed unit and a central unit, and the DU is the part that does a lot of the heavy lifting, digital signal processing, error correction, modulation, coding, to start that conversion of radio waves into IP traffic, and then the CU finishes that out, and then the core network is then what connects your device to the internet, gives you that network connectivity. And so the idea is in the midst of all this, we want to introduce cloud computing. We want to be able to segregate traffic and software-defined radio access networking, programmable control of your RAN resources that you could then automate via AI as well. Okay, this is sort of the picture here. You have cloud computers that are somehow very close to your cell phone towers. That could be done in a number of different ways, but the idea is your edge cloud computing needs to be arranged so that you get the kind of latencies that your application base needs. Now, the good thing, it's good to have a hard task sometimes. And in our 5G for AR/VR project, we were doing the synthetic scene generation, the frames to the headsets being generated from the edge computing, and so we had to be able to deliver that at least 60 frames a second. So with somewhere around 12 or so milliseconds of latency or less. We talked about this business of network slicing, so being able to segregate traffic so that you're not flooding the network with traffic that doesn't need to be there. And so you can imagine that this is just sort of notional, but have to have a place in mind to start architecture. So enhanced mobile broadband slice, slice that handles smartphone functions, slice for waste management systems, traffic management systems, and energy management systems. This is part of the ultimate scalability of the system. All right, now this idea of multi-level AI systems, as we've outlined it, on-device AI, Elon Musk has got, full self-driving, but, and then all the competitors to that have some sort of real-time decision-making on the platform. But there's more that could be done if you were actually able to share, information from a device to other devices through something like the edge level AI. And this is where you could, in our initial experiments, think about controlling large number of systems, drone swarms, in particular large number of robotic systems, autonomous vehicles on streets, buses. We started off thinking about a mobility as a service system for the elderly. It's voice activated. We'll show you a little bit of that later. Cloud-based, and then cloud-based AI to kind of put it all together. This is where we came from, and kind of putting it all together. Local decision making, sensor fusion, collision avoidance, anomaly detection down at the bottom. What's different about this approach to, say, overall autonomous vehicle navigation is that if you're going to do things like, say, share the location of one vehicle to the other and have some service, some quality of service commitments that make that reliable, you don't have to have the onboard AI discovering the whole world. And therefore, you can start to make that less complex, use less resources, and ultimately make things more safe. Your MEC level AI, federated cooperative AI, you could imagine things. I mean, we have shown that you can get the latencies down to where you could literally do a lot of the vehicle automation at the MEC and really start to minimize what's going on board. And then on board, you just need it if there is an anomaly to the system, there's enough onboard control to get it back on board, kind of like DJI does. And then up at the cloud, large scale citywide optimization, global model training, adaptive updates to AI, and kind of sharing of data between regions so that your overall route planning that's being delivered all the way and executed down at on board level is able to understand what's going on the other side of the region as you're going to get there. And this is just doing things like bringing what you see in Google Maps to life. Except now it could really do something. All right, this is, as we say in the USA, a bit of a seeing eye chart, but our reviewers wanted to see this kind of this kind of comparison, which was a good exercise. And the kind of the biggest difference, and you see this across the board, is these other systems don't have this idea of a complex cellular communication network to work with. They don't have the notion of edge computing yet, and MEC computing built into what they're doing. And so it's always good to get there. Always good to get there first. I think one of the biggest things that sticks that is one of the most important out of all of this is energy minimization. As soon as you start automating throttle control of vehicles, you really start to save a lot in energy and fuel costs right away. It's just amazing how inefficient our brains are at controlling throttles, and yet that's how all of our cars more or less are built right now. But when you start automating that throttle, your fuel costs go way down. And when you start, all of our models and simulations start showing that when you start coordinating traffic with knowledge of from vehicle to vehicle of the other vehicles, you can really improve the flow, therefore saving energy. And so this is where we started as an outgrowth of a navigation project, and going to a hackathon where back in the early days of Alexis, and then Alexa and going forward. So say, Alexa, I need to go to the doctor now, and this would summon the bus to get you. We also have an app, but the idea was to actually make voice activation come to life in the app. And just to make this come to life, so over on the left here, this is the IoT platform, 150 grams. As you're going to see here, it can even be powered with a network connection, but hook a battery to it or anything like that. So it's booting up. Over on the left, and it's generating a Wi-Fi hotspot based on the 5G connection. Over on the right, this is a smartphone that is connecting up to it, and as you can see, that's some pretty decent performance, and you can tell me if you get that kind of performance on your 5G network where you are. But there's a solid 552. And then here we are, then with a drone that you could order off of eBay and get that delivered pretty much anywhere in the world, and then connecting this to using the kind of the standard open source drone recipe around the world, PixHawk controller, Mavlink, Q ground control, and then starting to add some how should we say it, user added features to all of that. They're down there, sort of see as you start to navigate through the city at night, and this is just being connected to a regular public network and connected back in our lab, doing some testing, but verily it works. And then in terms of where we're going in the future, federated learning for AI model training. We are the first cell system that actually does end-to-end encryption. This is on the 5G standalone, which you can't buy yet, but we're the first people that are doing this around the world now. So we're going to be talking to your folks there in your government, and so your implementation here is that of a high performance service-based architecture. Everything is TLS secured right now, all the transactions, and so we are the first zero trust system then. And if you want post-quantum cryptography that follows the new NIST guidelines, we could put that in there for you as well. AI-driven threat detection, you folks have talked a lot about that, and the idea is to give you a way and a place to fit into the world here. And so the path ahead, we are now starting to, as we kind of got to our minimum viable product, version 1.0 release at the end of the year, and now we're starting to go out and do pilot projects, looking for, starting to get involved in large scale pilot projects, smart cities, and then various and sundry other efforts and things like drones and robotics and all of that, even to the point of starting discussions here in Brazil with local telcos here in country, and maybe we'll do that in the USA, but maybe not. And so we are looking for research collaborators, KSA, and please reach out and contact us. We're going to be visiting soon, and it would be fun to visit some folks and give some demonstrations and talks and whatnot. Okay, questions?
Okay, thank you, Jeffrey, for your presentation. Anyone have a question for him? No, fine. Okay, thank you so much.
Yes, thank you very much.
Yes, and Yes, we have a break now and we're going to start at 10:30. Okay, thank you all for attending.